Good morning everyone. Today we'll be discussing about the human eye, vision defects, polarization, thin film interference, and Young's double slit experiment. So first, the human eye. So the human eye is a complex organ functioning like camera to capture light and convert it into electrical signals for the brain to interpret as visions. Now we have the human eye anatomy. We have the sclera, iris, cornea, pupil, lens, ciliary body and muscle, conjunctiva, retina, optic nerve, macula, retinal blood vessels, and vitreous body. Now let's talk about the functions of the key parts. So first we have the cornea. The cornea is the transparent outer layer that bends light entering the eye. Next is we have the iris. The iris or the colored part that adjusts the pupil size to control light. Next is the pupils or the black opening in the center that expands or contracts to let in more or less light. Then we have our lens, a clear structure behind the iris that changes shape to focus light onto the retina. Next we have is the retina, or the light-sensitive tissue at the back of our eyes where images are formed and converted into electrical signals. Then now we have our optic nerves, which transmits these electrical signals from retina to the brain to form na the images or the visions. Then we have the sclera or the tough white outer protective layer. Lastly, we have the vitreous humor, a jelly-like substance filling the space between the lens and the retina. Next we have is the vision defects. So vision defects are common eye conditions, mainly refractive errors where the eye doesn't bend light correctly, causing blurred vision for near or far objects like myopia or nearsightedness. So now we have the normal vision and myopia. This is an example. So as you can see, in the normal vision, far away object is clear because as you can see, the light kinahit niya ang atong optical nerve, which is kanang maka-transmit na din og signal ato sa tong brain nga maka-form na din ta og image. Then sa myopia, nearsighted eye, the eyeball is too long far away object kay kanang unclear siya. So as you can see, the light kay wala siya ni reach sa atong optical nerve. That's why blurry ang atong makita if we have myopia. So how can myopia be corrected? So correction, we can use a minus lens to correct myopia. So here are the common refractive errors or blurred vision. So we have the myopia or nearsightedness, hyperopia, farsightedness, the near objects looks blurry, astigmatism or the irregular shape of cornea or the lens that causes uneven light focusing. Then we have presbyopia or the age-related loss of lens flexibility. So next is the polarization. So, polarization is a property of light that refers to the orientation of the oscillation in its electrical field. While light waves are transverse, meaning they vibrate perpendicular to their direction of travel, most natural light is unpolarized, vibrating in many random directions simultaneously. So, polarization occurs when these vibrations are restricted to a specific plane or pattern. So, like this one, as you can see, the light beam is kanang vibrate siya in different directions. So the polarization is kanang iya ganing i-restrict in one direction only ang pag-vibrate sa mga light waves. So some people they use kaning polarizing glasses because unlike regular glasses that just darken light, polarized lens cut specific reflections, making it easier to see the details. So pareha lang this one. So next we have is the thin film interference, wherein it is a wave phenomenon occurring when light reflects off both the upper and lower boundaries of a thin layer of material. So thin film interference is a wave phenomenon that occurs when light waves reflect off the top and bottom surfaces of a very thin transparent layer. The interaction between these two reflective waves result in constructive or destructive interference, creating the iridescent rainbow patterns often seen in soap bubbles or oil slicks. So these are the example. Next is Young's double slit experiment. Thomas Young was an English physician and physicist who established the principle of interference of light and thus resurrected the century-old wave theory of light. In 1801, Thomas Young performed the experiment that provided the first definitive evidence that light behaves as waves. So as mentioned earlier about the interference, we have constructive and destructive. So constructive interference it is a bright fringes where crest meet the crest. This happens because the path difference is integral multiple to the wavelength, while the destructive or the dark fringes wherein the crest met the trough, where this happens because the path difference is half integral multiple of the wavelength. So here are the formula wherein small letter d represents separation distance between two slits, and big letter d represents the distance of the slits to the observation screen, m for the order of the fringe or the integral, and lambda for the wavelength of the light.